Oh, okay. So, hi everyone. I am PhD student in UQuat in Quebec and University of Montpellier in France, under the supervision of Hugo Asselin, Adam Ali, Christelle Elie, and Martin Girardin. I present today my second PhD chapter with a publication just accepted in Quaternary Science Reviews, written in collaboration with Cécile Rémy and Yves Bergeron. The title is Temperature and Fuel Availability Control, Fire Size and Severity in the Boreal Forest of Central Northwest Territories in Canada. So about the context, we observed a rapid global warming and an increase of extreme weather events such as heat waves and intense and long droughts since the last decades. These changes led to an increase of the occurrence of large and severe wildfires. Some examples recently in Australia, California, Siberia, Amazonia, but also in the northern Canadian boreal forest, like in the Northwest Territories in 2014, where 3.4 million hectares burned. So if we observe the total annual area burned from 2009 and 2019 in the Northwest Territories, we see the exceptional nature of the 2014 fire season. But what we know about wildfires in the Northwest Territories? First, the fire season mainly spans from June to September. Lighting-induced fires are predominant, and the region is regularly impacted by very large fires. But if we want to compare the recent wildfire activity with the past, and if we want to understand how interacted fire, vegetation, and climate in the past, we need paleological data, which are few available at multi-millional timescale in the Northwest Territories. So our objectives were to reconstruct fire regime in Central Northwest Territories, to determine whether the recent wildfire regime was within or outside the Holocene range of viability, and to decipher the respective roles of climate and vegetation controls on past fire activity. The study area is located Central Northwest Territories in the Taiga Boreal Chilled West. It is part of the Tlicho First Nation territory. It is south but close to the tree line, and 4 lakes were sampled in June 2018. The region is mostly occupied by black spruce and jack pine more on the south. Some of the sample lakes were impacted by the 2014 fire season, like Lake Isaac, where watersheds were occupied by standing dead trees. And on the contrary, vegetation surrounding Lake Paradise was not affected by fires since some. About our methodology, we used lacustrine sediments from the 4 lakes to reconstruct regional biomass burn, fire frequency, and fire size index with the ratio between biomass burned and fire frequency. We extracted lacustrine sediments on the field, and we cut cores on the field and in the laboratory. And then we extracted and identified charcoal fragments in laboratory with Multicam software. We also counted pollen grains from one of the 4 lakes to reconstruct total pollen accumulation rate, interpreted as fuel availability and pollen accumulation rate of each taxa. Then we compared our reconstructions with past climatic conditions, such as mean summer temperature and dryness period inferred from hydrological conditions. About the results that we presented here, we show the fire regime history over the Holocene, and we note that fire frequency was relatively constant over the Holocene, while biomass burned was higher from 7.5 thousand to 5,000 calendar years before present. The FS index was higher during the first part of the Holocene and was increasing since the last 500 years, but remaining within the Holocene range of variability. So we compared fire history with fuel availability and composition reconstructions and with past climatic conditions. We can see on the left in red the vegetation dynamic history, showing a period of low vegetation abundance during the early Holocene. Then the total pollen accumulation rate increased markedly and decreased until present, despite a short duration peak during the last Holocene. And about reconstruction of past climatic conditions, we identified 3 main climatic periods. And at the early Holocene, large confidence intervals reveal more uncertainty in temperature estimations. We observe maximum temperatures during the middle Holocene, and then temperature decreased during the Neoglacial before drastically increasing during the last centuries. So our correlations and results show that periods with high temperature and moisture availability favored fuel availability and fuel flammability, suggested by the presence of black spruce during the Middle Holocene, with consequences on increasing fire size and severity. For conclusion, we conclude that warm and wet conditions favored fuel availability conducive to high fire size and severity in the past, and that fire size and severity increased during the last 500 years while remaining within the Holocene range of variability. These results corroborate previous observations on the wildfire regime in the region from 1965 to 2016. And now we want to understand how, what will happen with the fire regime in the future. And we suggest 2 possible scenarios. The first projects an increase of temperature and drought, conducing to an expansion of deciduous forest and an opening landscape, reducing the fuel availability and flammability, so limiting fire risk. And the second scenario suggests that temperature will increase as well as moisture conditions. So fuel availability will increase with possibly increasing fire risk. So thank you for your attention, and I want to thank the financial supports and all collaborators for the study.
Nice work, Dorian. Does anybody have any questions for him right now? Please raise your hand or use the chat. Or go ahead and speak away. Sylvie Gauthier has a question. Why would the deciduous species increase?
Sorry, can you repeat the question, Raphael?
Yes, why would the deciduous species increase under the dry scenario?
Why the deciduous species increase under
a dry scenario. Pourquoi plus de feuillus avec plus de...
Sorry, if you go at your last slide, you seem to suggests that deciduous forests would increase under hotter and drier conditions.
Yeah, it's more like it's more due to the increase of temperature. We can expect that deciduous species will expand to the north, replacing coniferous species.
Yeah, so are you thinking of trembling aspen or?
Trembling aspen and also paper beech, which are the species more present in the deciduous species more present in the Northwest Territories.
Okay, thanks.
Are there any other questions for him?
Yeah, I was wondering about the time time period you imagine your scenario, because if the deciduous forest is increasing, then the fire risk is limited. But then on the other hand, it means the forest will become to be invaded by conifers, and then finally you may have more fuel and go back to increasing fire risk. So your scenario is like for 50 years, and then after we shift to, in every case, to increasing fire risk, or?
So for the simulation, we will use the model LPGLM fire, and we want to realize different scenarios from 2020 to 2100.
I think that these are hypotheses that you're posing at the end of your research, right? So these are just trajectories or states that you think could happen, but this is not something that you know, right? Like, yeah, this.
It's two hypotheses about my third chapter, which is on the simulation of future fire regime in the Northwest Territories up to 2100.
Yeah, and I think that both Sylvie and Melanie are posing very interesting questions, meaning what are the feedbacks going to be doing in between those states? Because they could be jumping back and forth, right, as some kind of phases.
Yeah, sorry, Raphael, I don't understand.
Well, basically what they're suggesting is, even though it could turn into a deciduous forest, if these will be less flammable, right?
Yeah.
But at some point, maybe the fire regime could shift again towards coniferous forest at one point, meaning it doesn't necessarily push in one direction. It's going to be more of a fluctuation between the states, potentially.
Yeah, between the interaction between temperature, droughts, and each species.
Yes.
It's just to introduce feedbacks, but yeah, I think we can discuss it at another moment also. But it's really interesting, indeed.
Perfect. We're going to be passing on to Andy Enebel, and he's going to be presenting on learning from the present to improve paleo reconstruction. Thank you.